Hello, everyone. Welcome to our presentation on multivariable calculus. Here we're going to go over some basic idea of the two different types of quantities in mathematics and physics, engineering, and beyond in your career in STEM. So we can characterize quantities. Let's think of an example first. Say you go to the grocery store and you buy some amount of apples or oranges, and the price of your purchase is going to depend on the amount. Obviously, if you buy 10 apples versus one apple, then 10 apples is going to be more. So we can characterize quantities with an amount, but we can also characterize some quantities. This may seem a little foreign to you, and it's okay if it is, with a direction as well. But you're probably going to say to me, well, how can an apple have a direction or an orange have a direction? Well, we're going to see that. This is a different type of a quantity. So let's make this more concrete now, okay? Let's say I give you 3 stars. 3 stars. And this is some kind of quantity, correct? And I ask you, I say, what's the magnitude of this quantity? Well, you can just count them. 1, 2, 3. So to describe this quantity, I would say it has magnitude 3. Say I gave you 2 squares. 1, 2. This is a quantity over here. Now, what's the magnitude of this quantity? We can count 1, 2. So the magnitude, this quantity would have magnitude 2. Notice how these quantities have only a magnitude. They only have a number associated with them. We call these quantities scalars. Scalars. So scalar, a quantity with only, it's a keyword, only magnitude. So these stars up above, right here, and these squares below them, these are scalars because they only have a magnitude. You can fully describe them by just counting them and telling me that there's 3 stars, there's 2 squares. Excuse me. Now we'll see. Let's say that, the different example, say I was a weatherman. And I tell you tomorrow there's going to be a 45-mile-per-hour wind moving northeast. So I've given you some quantity, and this quantity describes the weather tomorrow. But notice I gave you 2 kind of different things. I gave you a magnitude of the wind. This describes how strong the wind is blowing. And I've also given you a direction that the wind is blowing in. Correct? A direction. I told you it's moving 45 miles per hour, but in what direction? I told you northeast. So this gives you a magnitude and a direction. That's not a scalar because a scalar only has magnitude. We call quantities like this vectors. And vectors are a quantity, or this is how we describe them, a quantity with both, this is another keyword, both magnitude and direction. So with this wind example, I told you, once again, if I'm the weatherman, I tell you tomorrow there's a 45-mile-per-hour wind moving northeast. I gave you a vector quantity. Say I didn't tell you it was moving northeast. I just told you tomorrow there's just going to be a 45-mile-per-hour wind. I would have given you a scalar quantity then because it only has magnitude. So let's summarize this now. So if we were to go back to our idea of a quantity, there's 2 different types of quantities. There's scalars. Scalars have only magnitude. They only have a number associated with them. They can be fully described by that number. And there's also another type of quantity, vectors. And vectors can be described by having both magnitude and direction. Think of that wind example I told you. If I didn't give you northeast, I would have given you a scalar and direction. So this is a very fundamental, rudimentary example, but as we progress onwards in multivariable calculus, these ideas of scalars and vectors are going to become more mathematical, and hopefully you get more of a grasp of them then. See you soon.